Here's an example that deals with finding the work for something. A spring has a natural length of 40 centimeters. A force of 8 newtons is required to hold the spring at a length of 50 centimeters. How much work is done in stretching the spring from 50 centimeters to 60 centimeters? So because we have a spring, we know that we're going to use Hooke's law, which says that the force is proportional to the distance at which a spring is held away from its natural length. So in this formula, F is the force, K is a constant that we need to figure out, and X is the distance away from its natural length that a spring is held. For our problem, we know the natural length is 40 centimeters. So if our spring is held at a length of 50 centimeters, then the X, the distance away from the natural length, is 40 minus 50, which is 10 centimeters. However, we usually want this in meters, so we're going to write that as 0.1 meters. While we're at it, if we're talking about stretching the spring to 60 centimeters, that means the distance away from the natural length is 20 centimeters, 60 minus 40. And converting it to meters, that's 0.2 meters. So now, let's figure out what K is. It says a force of 8 newtons is required if X is 0.1. So using this equation, we know the force is 8 newtons and X is 0.1. So 8 equals K times 0.1, multiplying both sides by 10, we figure out that K equals 80. Now, to find the work, we know that work is the integral of the force, and our bounds are 0.1 to 0.2 because we want the work done stretching the spring from 50 centimeters to 60 centimeters. From Hooke's law and the work we did finding K, we know that the force is 80x dx. And then we just have a simple integral. Our antiderivative is 40x squared. We're going to evaluate. So we have 40 times 0.2 squared minus 40 times 0.1 squared, which is 1.2 overall. Because this is work, our unit is joules.